Can I have the slide? Okay, so this is a three-part technical session. So the first part is the morning part today. So it will be up to 10:30. Then we have a second part at 2 o'clock to 2 p.m. to 3:30 p.m. And then there will be a tea break. Then we'll come back at 4 to 4 p.m. and the session will continue up to 5:30 p.m. So I hope you'll enjoy. So actually, I expected more participants. So the topic is very is like a hot cake. Is a deep learning, data science, image classification. So I hope you guys enjoy the session. So can I have the access of this? So So actually, it's a tutorial session. That's why I prepared a PDF file so that I can share with you guys. So in the second part, I will also share the code so that you can actually have your hands-on training. So I thought there will be computers for you guys so that you can have your practical experience. So it's fine. So I will provide the codes and I will also provide the documents. So that will really help you to understand what about the deep learning, data science, or so it's a we will apply deep learning for data science or image classification. So we'll talk about this. Full screen. Okay. Okay. As you all know that I'm Dawan Farid from Department of Computer Science and Engineering, United Nations University. So I have also my short bio here. You can actually, if you're interested. So I'll share this document with you guys. So this talk is about deep learning. So there are some symbols here. So I will start with some symbols. Before that, let me talk about deep learning. What is it? So deep learning is basically the branch of machine learning. And machine learning is a branch of artificial intelligence. So these are the hot cake, right? So all the people talk about deep learning, machine learning, advanced artificial intelligence. So in machine learning, normally we used to use these symbols. For using symbols, there is no predefined rules. So different researchers, authors, scientists, they use their different mathematical notations. So commonly, I found these in the literature. So mostly the equations and the complex figures that we'll see that will actually explain with this kind of mathematical notations. So here, if you look at the Roman X, which is basically the training data. So what is, let me ask you a question. What is machine learning or AI or deep learning? What is AI? So, right. Machine learning is a learning procedure for machine, right? So you see, advanced AI, machine learning, deep learning, they have one common similarities, like these things actually try to mimic human, like how human thinks or how actually we process the information. So how actually we perform a task. So AI want to perform a task as like a human. Machine learning also want to do that. Deep learning also want to do that. So all these three, AI, machine learning, deep learning, they try to perform tasks as like human. So I'm giving a talk. So instead of me, maybe there will be a virtual Dawan Farid or maybe a robot Dawan Farid who can actually conduct this tutorial session. That the main objective, motivation of AI, machine learning, deep learning. So AI, machine learning, deep learning, they are in the same domain. So AI in a broad area. Inside the AI, we have machine learning. Then inside machine learning, we have deep learning. But there is a difference between AI and machine learning. So AI is basically something that perform tasks as like a human. Say, for example, you can play tic-tac-toe or chess with machine. You will feel opposite of the screen, there is a human actually playing with you. So AI basically perform tasks, but rules are given by the experts. So the human beings or experts like us who actually extract the rules from the data, who's finalize the rules, and who actually program that rules to the machine, and machine actually follow that rules. That's basically artificial intelligence. So it performs tasks like a human, but the rules are extracted by expert, another human or another machine or someone else, and that rules are programmed in a machine. So machine actually follow that rules and perform the task. That is artificial intelligence. And what about machine learning? So machine learning also perform tasks as like a human or as like AI, artificial intelligence. But here the rules are extracted by the machine itself, not the humans, not the experts. So we'll see how machine can extract rules to solve the problems. Like normally, these call, say, machine learning is broadly categorized into supervised or unsupervised learning. So it basically extract rules for solving this kind of task. So the machine learning is like, you'll not give the rules to the machine, you'll not machine what to do, but machine will learn through the experience. So machine will itself extract the rules and perform the task. Right? Is it clear to everyone what is the difference between artificial intelligence and machine learning? And deep learning is another subdomain of machine learning, where the features, like say for example, to perform a task from the data, we need to extract the features. In machine learning, that feature extraction process is manual. So the humans, it's like hand engineering process. We have to extract the features from the data. But in deep learning, we'll see it automatically extract the features. That's the difference between deep learning and machine learning. So AI, deep learning, machine learning, they perform tasks, but in AI, the rules are given. In machine learning, rules are extracted by the machine. In deep learning, the rules are extracted by the machine, and also the features are extracted by the machine. So that's more advanced form of artificial intelligence or advanced artificial intelligence. Is it clear to everyone, the audience? Okay, thank you. So you see, we'll see some of the mathematician works like X that represent, small x represent the instance, capital X represent the input features, Y represent the dependent variables or the goal. If we talk about the supervised learning problem, if we have only data, we don't have the Y or label data or dependent variable, then we can say it's a unsupervised learning data. So we have say for example, the cost function, C represent for cost function, F represent for functions. So we'll see. So these are the mathematical symbols that normally we use in machine learning. So okay, so I already covered about the computational intelligence. So computational intelligence is a broad umbrella. So in this umbrella, we have AI, machine learning, deep learning, like knowledge discovery from data, pattern recognition, data mining, all these courses in computational intelligence, which is also known as soft computing. So I already covered this. So I started the tutorial session with the two quotation or notes from two renowned scientists. One is Einstein. He said, imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. It's really important. So you guys are graduating from this university. So is this means that you will be knowledgeable person? Your certificates say you are knowledgeable. Okay. So how can we say we are knowledgeable? Say I did my PhD 10 years back. Then I have a couple of postdocs. Am I knowledgeable? I think no, right? So knowledge means if I can perform a task accurately, if I can make a decision accurately, then you can say he has the knowledge about it. Say, for example, if you ask me to pull the rickshaw, it will be a very difficult task for me. If you ask me to irrigate something, so if you tell me to go to the field and do something there, that will be really difficult for me because I don't have that knowledge, right? Though I have a PhD and postdocs, but I have not particular domain knowledge for that task. So the thing is, when actually perform tasks, we take the right decisions. That's called knowledge. So actually, knowledge came from information. Uh, so there's another one. So intelligence is the ability to adapt to change by the Stephen Hawkins. Okay, so we already talked about the machine learning. So machine learning is a subset of advanced artificial intelligence. So there is a few definitions here. One of my popular definition is like by the Tom Michel in 1958, say, well-posed learning problem, a computer program that's said to be learned from experience with respect to some task T and some performance measure P. So if the performance on task T as measured by performance P improved with experience E, that's called machine learning. So machine learning is basically performing something, learning something through the experience, and you will improve your performance through that experience. And I have one definition for, it's my definition, like machine learning is the process of extracting rules from big data for knowledge mining. So it's more precise definition. So nowadays we don't have a data, we have big data, right? So I'll not explain too much about the machine learning because this session is about deep learning. So I'll try to move to the deep learning very quickly. So whatever we do with advanced AI, machine learning, or data mining, or deep learning, so we actually play with data. So data is for me, data is something that we actually store in the machine. So data is basically the raw material. So from data, if we process the data, if we cook the data, we have information. And if we process the information, we have knowledge. So I talk about the knowledge. So knowledge is really important. So if you can train a machine that can process very complex information for you, which is really difficult. So we'll see the machine has more computational capabilities than human. It's about more than 20% computational capabilities than human. So human can think, we have our analytical power, but when I give you, say for example, if I ask you to add 2 plus 2, you can easily say it's 4. If I ask you, what about 40 plus 40, you can say 80. But if I give you 20-digit complex number, and if I give you 2 number and ask you to multiply them, how long it will take? If you're very good in mathematics, maybe it will take 5 to 10 minutes. If you like me, very poor in mathematics, it may take 30 minutes to 1 hour. We don't know, depending on our mathematical skill, right? If we multiply 2 complex number. But if you give 2 complex number to a machine and ask machine to multiply, how long it will take? Maybe a fraction of nanoseconds, right? You just give the number and press the enter button, you'll have the result. That's the thing, like machine actually can process the data faster than us. That is the beauty of the machine. So to have the knowledge, we'll see, we need to have very complex computational calculations or tasks that is quite difficult by the human beings. So if you can train a machine who can tells you about the gold price, what will be the gold price after 6 months? You know the gold price is fluctuating, our oil price is fluctuating. If we can predict this kind of prices, like, okay, what will be the gold price of next year, this time? Or if I buy the share, I'll lose the money or I'll gain the money. So if you can take these kind of decisions by using machine, so that will be wonderful. Like Angel, you were asking Angel. So I want to buy some shares, or I like to invest some of my money to buying gold. So it will be profitable for me, or there is a chance for disaster. So that's thing. So the first part is quite introductory part. So from the next session, we'll go more deep. And so it's a deep, you see the deep learning. So our learning will be deep to deep with the sessions. So this is all about data. This is about the data types. I'm skipping this. So I'll share these documents with you guys. So if you think it is, you can, right. Okay. So if you read this one, that will be really helpful for you guys. So okay, let me skip this. I'll come back to this. Okay, let's talk about this machine learning process, because I'll go to deep learning very shortly. Before going to that, I'm just trying to briefly introduce machine learning to you guys. So machine learning is something that we extract the rules from the data, and that rules are extracted by the machine. So to do that, there are six process. So, or if you want to deploy a machine learning algorithm like deep learning, there are six process here. The first thing is data collection. We have to collect the data from the source, from the nature. And after having the data, there's called data preparation. So data preparation has actually three phases: data preprocessing, data sampling, and another is called visualizing the data, exploratory data analysis. So after having data, it is not like that we are building the model. We need to preprocess the data. So there are a lot many things. So when we preprocess the data, we'll see we need to actually uh, address the missing values. We need to balance the data. We need transformation. We need discretization. So there are a lot many processes for data preprocessing. So I'm skipping this because this is a deep learning session. So I'll go to that. And next is model building or training model. That is basically the deep learning that we'll talk about in this session. So after having data, we process the data, then we build the model, then we test the model. So are we happy with the model? What about the model performance? And then we actually deploy the model, and the final step is called retrain model. Say for example, after a certain time, after 6 months or 1 year, you will check the validity or the performance of the model. Is it the model is giving the right decisions, or what's the accuracy of the decisions by the model? So that is the basic steps of machine learning. And machine learning broadly classified into so there are several types of learning problems in machine learning. Among them, supervised learning is very common, where we have classification and regression problems. We have unsupervised learning, where we have only the data. We can use unsupervised learning is known as clustering. We can group the data. We can cluster the data. We have a semi-supervised situation, like we have a data with labeled and unlabeled samples. So that's called semi-supervised learning. We have active learning. So in active learning is a machine learning process where machine learn, but with machine learning, an expert or another machine actually help machine to boost up the learning. So that's called active learning. Then we have transfer learning. So we already have a model. We can use that model for solving another different task. That's called transfer learning. We have reinforcement learning, which is like say you tell machine, if you can perform well, you will be rewarded, or if you do some wrong decisions, then you'll be penalized. So we'll deduct the point from you guys. So this very basic introductory chapter for you guys, those who are really interested about machine learning, I'll share this document. Basically, I'm trying to write something as like a book, so it's really helpful for you guys if you actually just review about the machine learning. Please sit and say, right. Okay, so retrain model, that means, say for example, you build a model and that is working very well, but what about after 1 year? What about after 2 years? So there's a one situation like called concept. We are developing concept, and concept may be changed over the time. Say it's a summer, it's a hot summer. So instead of wearing full t-shirt, full shirt, I prefer to have a t-shirt, right? As a professor, this is my favorite dress, like jeans and t-shirt. Uh, I'm not a formal guy. So, but this dress will not become suitable in the winter. Say if I come here in next January, in a winter, I will not be feeling comfortable with a simple t-shirt, right? So you see that over the time, this concept can be changed. So you build a model in summer, so you don't know that will how it will perform. You build and test model in summer. Say for example, you want to predict the trend purchasing clothes from a supermarket. So you train the model on summer. You don't know what will be happening in winter. So after 6 months or after a few months, we need to retrain or check whether the model actually performs well or not. So because in winter, indeed, I will not wear a t-shirt. I will wear. I think, okay. So is it clear to you guys why we need retrain the model? So this is data preparation. So we have the time limits. So I skip few things very quickly. So this is one thing I would like to really talk about data splitting. That's really important in deep learning. So data splitting is basically when we have a data, we split the data into three sub parts. First part is about training data. That's like 2/3 of the data, 70% data or 80% data we normally consider for training. So we actually keep large portion of data for training, and then rest of 1% of data or 30% of data, say 2/3, 1/3 of the data or 30% of data, we keep it for validation and testing. So validation and testing is the two separate data. So we divide the data into training set, validation set, test set. So training set, that means we build the model. Validation set, like when actually we are building the model, we are testing the performance of the model. Like we'll adjust the weights, we'll adjust lot many parameters. So how the model's actually performing on training, we test it on validation set. So that's validation set. When actually we build the model, we have our complete model. In that case, we actually use test data to perform the final accuracy or final performance of the model. So training data, validation data, test data. So when actually we build the model using training data, we test the model performance using validation set or validation data. When the model training is done, we actually test the final performance on test data. So that's the data is splitting, right? Training, validation, and test. Is it okay? So you can see the figure here. So the first part, the large part is about training data. The validation set, when actually we are doing the training, we actually measure the performance of training data using validation set. And finally, the test set is separately used to test the performance of the final model. Is it clear? Okay. I think that's enough. Let's go to deep learning. So these guys, these things are you. So I have taken, yeah, please sit and ask the question. Okay, so interesting question. So, okay, first thing, we train the model, right? So when we train the model, actually model train on training data. So training data is seen to the model. So when actually we have the for the training data, we have X and Y, independent variables and dependent variables. So when actually we train the model, we know what's the Y, what's our dependent variables. So okay, so if I tell you that's a water, right? It's not a soft drinks or hard drinks. It's not like a Jack Daniels. Have you seen Jack Daniels? No. Okay. So have you seen Coke? Okay. So you are well known with water and Coke, but you don't know Jack Daniels, right? It's one of the favorite band, JD. So if I say, okay, this is champagne or Jack Daniels, then you say, oh, then you say, oh, it's a liquid. It's in a bottle, so it may be used for drinking. You don't know. So test data is totally unseen to the machine. That's why sometime or in real cases, test data may not give you the good accuracy. So when actually train the model, so you used to drink water, it's very common to you. You used to drink soft drinks, right? Or coconut water is very common to you guys, common to us. But say for hard drinks is not common for us, right? As a Muslim, as a Bangladeshi, we are not well known with hard drinks. But if I train, so this is your training, right? But if I give you water, you can easily say it's a water. But if I give you something like a hard drinks, that will be really difficult for, that's totally unseen to you, right? And say I'm teaching something, and in the exam I'm giving something else. So that's a test, right? So whatever we discuss, say if I teach you 2 + 2, 4 in the classroom, and if I give you 2 + 2 in the exam, that's very common to you guys, right? So you already have the experience. 2 + 2 is 4. But if I give something different, that's test. So, and normally what we do, we do not do well in the test, right? So that's why we need separate test data to measure the actual performance of the model. Say if you can recognize the drinking water, if you can recognize the soft drinks, you can recognize hard drinks. So some part of Europe or America, hard drinks is very famous, right? So that's why we need separate test data. So this is the one of the picture I found in Facebook. Some of my friends share. So what about data science? So after deep learning, the next topic is data science. So you see, the human brain is about data science. So data science is all about machine learning. In the first left corner, you see the top left corner, the machine learning. We have classification, regression, clustering. We have deep learning, dimension reduction. So the major part in data science is about machine learning. So we have something like, say, for what about data analytics, like feature engineering. So from the data or from the image, we need to extract the features. That's called feature engineering, feature selection. So EDA, exploratory data analysis. For data sciences, you may have statistics, linear algebra, or differential calculus. So these are the things, like at a glance, what a data science. For data science, Python is very popular, R is popular, Julia is a popular language. So these are programming language. Even Java is also popular language. So before 23 years back, I started learning C programming. That's my first language. I learned C programming. And then in 2000, 22 years back, I learned Java. When I was doing my PhD, I learned R programming. And then in 2015, I learned Julia. Do you know Julia? We have Julia is a girl who actually stay in your girls' hostel. You know the Julia? Okay, you must know. Do you guys know Julia? So there is a student hostel, right? How many student hostels here in? 5 student. No, it's a girls hostel. 3. Okay. And do you guys know where Julia stay? In, right? Okay. Julia is a programming language, right? So you know C programming? You know Java programming? Similar, like a Julia is a programming language. So Julia is not like girl is staying in a girls hostel. So if we invent something like something a programming language, we may give a name like Joleka. It's fine. You know the Apple, I normally used to use Apple Watch, Apple iPhone, right? If we create this band, we may say it's a jackfruit, not Apple, right? So you know the Python is not the Progenius snake, it's a programming language, right? So, okay. So there are some IDEs. Do you know what is IDE? Integrated Development Environment. So normally for this kind of language like Python, Julia, Jupyter is really famous. Jupyter stands for Julia, Python, and R. So Jupyter is a notebook, so which commonly used by the data scientists or you guys. So we normally use Jupyter. So if you install Anaconda, we have a Jupyter. Even there is a wonderful tools by Google called Google Collaboratory, Google Colab, that allow us to write code in using Jupyter, Python code, R code, or Julia code in a browser. So I thought there will be a computing facilities, so we can all do some hands-on training. So I'll show that in the final part of this technical session, how we can actually use Jupyter for doing say Python programming or Julia programming. Sorry? Right. Okay. So this is deep learning. So so still I have 30 minutes, right? So this session will be up to 10:30, right? So in next 30 minutes, I will try to introduce deep learning to you guys, and with the time, we'll go deep to deep learning. So, okay, so before going to start deep learning, I would like to start with another quotation, AI, that we explained, right? We already discussed what is AI. Deep learning, we also discussed about deep learning, machine learning. So artificial intelligence, deep learning, machine learning, whatever you are doing, if you do not understand it, learn it, right? Otherwise, you are going to be a dinosaur within 3 years, by Mark Cuban. So he's a theoretical physicist. Right. So do you get the quote? AI, deep learning, machine learning. If you don't understand it, learn it how to use. Otherwise, you are going to be a dinosaur. It's like a metaphor, right? So you must need to know these things: AI, deep learning, machine learning. So it's not about, say, for I'm a computer scientist, it's not about like only the computer scientists or computer graduates, they will talk about deep learning or this kind of language. So nowadays you see the doctors, the army officer, pilots, they also use deep learning, machine learning in their areas, respective areas, right? It's not so. Those who are from computer science background, I always ask my student, go deep into the algorithm. You need to know how this algorithm, what is the internal mechanism, architecture of a algorithm. But for other disciplines, say for someone from business school, he or she doesn't need to know how deep learning actually works. He need to know how to apply deep learning. So if you just know, give input and get output, that's good enough. But if you are a computer science student, or say you are studying electrical engineering or computer engineering, then you must go deep inside to the algorithm, deep learning algorithm, right? So you need to know the internal mechanism. So what is deep learning? Deep learning is a branch of machine learning, which is also a branch of advanced AI or artificial intelligence. So deep learning is nothing else. Deep learning is basically artificial neural network, right? So it's a neural network, and that is artificial. So where we get natural neural network? Right, in our brain, correct. So in our brain, we have natural neural network, right? So in, so do you know how many neurons we have in our brain? 10 crore million. Any guess? Anyone has any guess? 86 billion. 86 billions, which is like 8,600 core neurons in our brain, right? So this is like huge network. So we are the humans, we think, okay, why not we can build artificial neural network which can actually process information like human, like how we actually perform the task. We want to perform the task by the machine, and how we actually perform the computation. We want machine to perform that computation. So that's why we say, okay, it's an artificial neural network, and it actually try to do the task as human do. Like, okay, how we actually process the information, the neurons actually wants to or try to process the information in the same manner. So what's the advantage of, say, when we say it's a deep learning, we talk about the deep learning, but it is a form of artificial neural network. So what's the difference between artificial neural network or deep learning? Any idea? When we say, okay, right, artificial neural network and deep learning, right? Okay, so basically deep learning and artificial intelligence, they are same. Deep learning also an artificial neural network, but deep learning should have at least 2 hidden layers. So when you have minimum 4 layers, we'll talk about the structure of a neural network. So normally artificial neural network has input layer, hidden layer, and output layer. So if you have a more than 2 hidden layer, 2 or more than 2 hidden layers, or if you have a at least 4 or more than 4 layers, we can say it's a deep neural network or deep learning, right? They are basically same, right? Mm-hmm. Mm-hmm. Right, 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 right. Right, right. So there are some form of deep learning. One you mentioned CNN, we have RNN, right? In CNN, I will discuss in my talk. Like in CNN, we have 4 uh, components, like convolutional layer with activation function ReLU. We have pooling layer, and we have fully connected layer. We'll talk about. So in CNN, convolutional network or ConvNet, we extract the features by the machine through the, we actually uh, minimize the features, skews the features through the convolution and pooling layer. So we'll talk about this. So that's the difference between deep learning. That's basically CNN, convolutional neural network. So I was asking, what's the difference between deep learning and AI, artificial, sorry, deep learning and ANN, artificial neural network. They are basically same, right? So, okay, let's just briefly talk about the history of deep learning. So it's not new. It's not new. So in 1952, the first we have the gradient descent concept. So gradient descent is a wonderful algorithm. It's a concept like do you know what is gradient? When we can say gradient? Okay, derivation, fine. Right. So either optimal local minima or global minima, whatever we say. So gradient descent is a concept like, so normally gradient means when we use more than one derivations or derivatives in a single function. So that's called gradient, and it's a descent algorithm. So that will help us to find the optimal value for a parameter where actually the loss is minimum, right? So this concept, and stochastics gradient descent is a successor of gradient descent, which actually deals with the big data. So stochastics gradient descent actually deals with some part of the data. So that's basically gradient descent concept, and that is not new. It's about 70 years, right? 70 years back concept, 1952. And in 1958, we have perceptron. We have a concept of neuron or a node and perceptron. We'll talk about how a particular neuron actually works. And then in 1960, we have multilinear perceptron concept. So we'll talk about this in this tutorial talk. And in 1986, we have backpropagation algorithms. So so CNN is not new. That introduced in 1989. You see, these concepts are very old concept. And also in 1995, we have long and short-term memory. We'll talk about this also in this session. So these things are not new. But in 2010, so mostly in early 2000, when I was doing my PhD, that time deep learning was not so popular. So in that time, they talk about the probabilistic algorithms, not like deep learning. And deep learning came back in 2010 with a new name, deep learning. So the artificial intelligence is renamed as deep learning in 2010, right? So and then in 2013, we have ImageNet challenge, and 2015 we have AlphaGo challenge. So these two is really interesting. So ImageNet is a competition where a man or a human actually give 1,000 images, and he need to recognize, or she need to recognize the image. So you will be given 1,000 image, like 100 birds, hundreds animals, 100 people face or something, and now you have to actually recognize them. So these task was performed by human and also the machine, and machine actually performed 20% better than human. And that time the people thought, oh, what is this? This is a deep learning, and it performed better than humans, so it can be something. In 2015, AlphaGo is a game. It's a national game of Korea. It's a very complex one, like chess. And in 2015, the machine defeated national champion of Korea and world champion of Go. So that's why deep learning become very popular. So there's another reason why today deep learning is too popular. So because 20 years back, we don't have a big data. We had a data. So now we have big data, and data is something, we talk about data information knowledge, right? We started with basic intros. So to train deep learning model, we need a big data, large number of data. We need volume, variety, and velocity. So that's why deep learning become very popular nowadays. Even we have very advanced hardware and software. So now we can actually use GPU with CPU, right? So before 15, 20 years back, we have only CPU concept, like central processing unit. But now we have a GPU, graphics processing unit, right? Even we have some other small devices called accelerator, Google accelerator, that's like a pen drive. You can actually mount that to your machine, and that also boosts up the performance of your computational capabilities. So we don't have this kind of device 20 years or 30 years back or 15 years back. So that's another reason. Even nowadays, we have, say, everyone is a machine learning researcher. Everyone knows machine learning, and they have papers. Even in this conference, I think most of the papers about machine learning, they all know machine learning. Why? Even not like a computer science graduates or students. So students from business school, from other disciplines, they also a machine learning researcher. Why? Because of, not like a demand, because of sklearn. scientific kit learn, S science K kit learn, psychic learn, and that's actually make the things very easy. It is not like that we will actually use the libraries, but the concept is sometimes we need to actually develop our own methods, own classes, own functions, right? So that's say nowadays, the Python programming. So we don't need to declare the data types. We don't need to declare data structures. But in C programming, Java programming, we never think of if we miss a semicolon, we had an error, right? We just have one error. But in Python, that makes life easier. Julia makes life easier. Even there's a one language called TensorFlow by Google. That's based on Python. So you don't need to mention data types, data structures. You just call some libraries from sklearn. So to build a deep learning, I will share the codes in the final session. Like you see, that's about 30 lines or 20 lines of code that you can actually build deep learning model. So you can build CNN model with a less than 50 lines of code. It's like a very simple. And so the code from Kuben, like say, if you don't understand it, learn it. So you need to know how to give input and get output. That's it. You don't need to know how inside the mechanisms are going on if you are not computer science student. So that's why deep learning was not so popular before 10 years or 20 years back. Now it's become really, really popular. So if you talk about the building neural network or architecture of neural network, so we have 3 layer: input layer, hidden layer, and output layer. So I'll share this doc with you guys so you can just read. So this looks like this figure. Like we have input layer. So if you look at the very left corner, these circles x1 to xm, these are the inputs. So we talk about the x and y. So the very left corner we have x, and very right corner we have y. So x are the independent variables and y is dependent variable. And inside, so input layer and output layer. So input layer takes input from the outside world, pass the input to the input layer, actually do not do nothing. It's actually pass the value to output to the inside neurons, inside layer, and inside layer and output layer do all the computations, all the things, and output layer actually returns the process or the output to the outside world. So this looks like a artificial neural network. So I'm talking about single layer. Also, it's a single hidden layer. So typos, like it's a single hidden layer neural network. We cannot say this is a deep neural network. It's an artificial neural network. So what's the difference between AI and deep learning? So let's go to the last slide. I'll come back here. So this is basically in the last slide, you see, this is called deep learning because we have more than at least two or more than 2 hidden layers. So this is like a deep learning or deep neural network. Is it clear to you guys? Okay. Okay, so let's talk about what we have in a single neuron. So X is basically the inputs. Each of the input has its corresponding weight, omega or W. And say, for example, say y hat. So there's a difference between what I start with some mathematical symbols like y and y hat. So y is basically the dependent variable, actual output, and y hat is basically the predicted output by the machine. So you see there is a hat top of y, and y hat equals to a function of g, or you can say f, whatever. So omega 0, or you can say w0, omega 0 plus summation of I equals to 1 to n xi times yi. So this is basically the function. Say, okay, so this is basically the weighted sum calculation that goes through a function, either linear function or not linear function. So normally we deal with the not linear function. So this is a neural network looks like. Say we have inputs x1, x2, dot, 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 xn. Each of the inputs has their corresponding weight, omega 1, 2, 3. And these weights, we calculate the sum, the first. So this is the part, like the sum and this function, this together a neuron. So neuron has 2 parts. It's calculate the weighted sum, and then it's calculate the pass the weighted sum through activation function to have a output. So initially it actually calculates the sum and it passes the sum to the function and to have the x hat or the expected output. So this is a single neuron and for forward propagation. So this is the concept. So here you see in our inputs, we actually do not have x0, but we add x0, another additional input here in this figure. So you see x1 to x3 is the input, but additionally we add one input which is called bias, that is x0. So if you know the regression problem, how to solve a regression problem, say for we have x and y, then if you want to draw a line, a decision line or a classifier or a machine, then that is basically y hat equals to omega 0 plus omega 1 times x1, right, or x. So here omega 0 is considered as an intercept, and the inputs omega 1, 2, 3, that's considered as a slopes, right? Slope, intercept and slope. And so in a neuron, in a particular neuron, we can add another extra input as a bias. So now omega 0 is like a intercept. We also need to have the weight for omega 0, right? Is it clear? And we do the same task. We actually calculate the sum, and then the sum is passed through a non-linearity function or linear function to have the y hat. Any questions up to now? So this is like this. So we actually, so if you look at here, so omega 0 is a weight for bias plus I equals to 1 to n omega I times xi, where x is the input. And for bias, the x0 is always 1. You see the x0 is constant, which is always 1, right? Okay. So we already talked about what is we have in a neuron. So I told that we have 86 billions of neurons in our brain. So I just talked about a neuron, a single, how it looks like, how it works. So it actually calculates the weighted sum, pass the weighted sum through a linear or nonlinear activation function to have y, right? Is right. It's a bias. It's a value for intercept. So it will be always 1. So it's the x0 is always 1. It's a constant. It will be always 1. But if you want to, if we say for x are given, all the x are given, we have nothing to do with the x. Y is also given. So we need to find the loss, like difference between y and y hat, right? So we'll minimize the loss through weights, omegas, the weight of omega 0, omega 1, omega 2, omega 3. But so that's why, so x0 is considered as an input, which is not given in the training data set. That's why omega 0, x0 is always 1. Is it clear? What? We don't update the inputs, we update the weight, right? So we need to update the weights. That's what I'm saying, right? We need to update omega 0 to omega 3. Right, weights of bias will be updated, but input that will not, that is fixed. X0 is always 1, but the weight omega 0 is the weight for x0, that will be changed, that we will update. Is it clear? But we have nothing to do with the inputs and output. That is given. We have only the things like weight. We need to change the weights. That's it. We'll see how gradient descent or chain rule will help us to have the minimum value or weight value to have minimum loss. Okay. So let's talk about activation function. So activation function is a core part of a neuron. So activation function can be linear or non-linear. So most of the cases in real life, we have non-linear situation. We cannot say we have a data with a linear distribution. That is very rare. Even we have a linear distributed data, which is really rare. And we can actually use linear regression to actually classify the linearly distributed data. So if the function is linear, linear, we have a linear activation function. It doesn't do anything. No transformation between input and output. What the weighted sum we have, that will be the output. So when we say linear, so actually there is a no activation function. So it's what is the weighted sum we have. So we actually have the input multiply with their weights, we have weighted sum, that is basically the output. So that is called linear activation function. But in real life, we normally have non-linear activation functions. So non-linear activation function means there should be some transformation. So I mentioned here three commonly used non-linear activation functions, which is sigmoid function, tanh function, hyperbolic tangent function, which is known as tanh, rectified linear unit, ReLU. ReLU is commonly used in CNN. You talk about CNN. So even there are other activation functions, but these three are really, really common. So you must need to know how to activate them. So sigmoid function is very simple. 1 by 1 plus e to the power of x. So x is x. One, so one is true, but extremely one is so if we use so we need to have a say we already have two input x1 is to given data set, but we add bias, right? That is it itself. Add additional input that is x0, which is 1, and now we omega 0, omega 1, omega 2, we need to calculate the sum. We pass the sum to the sigma, say for example, sigma activation function to have y hat. So now you see, I mentioned the weights here, but it will be really interesting if I just remove the weights, like remove the value of the weights, right? Say, if you say that's called forward propagation. So we'll actually change the word. Say initiate. So normally, what will be the value of words? In generally, for deep learning, we assign the weights between 0 to 1. So any random value, 0 to 1. And then we check. We actually calculate the weighted sum, pass the value to the sigmoid function, and we have the output, and we check whether the y and y hat is same. similar or not. Say if the loss is 0, then we're very happy. So weights are correct. If we have something different, so say for example, y should be 0 and we are having 1, so that is something different that we are having. Then we need to actually change the weights, right? So this is a concept of forward propagation. So the weights are given here. I just given one example that we can actually solve and get problem with a single neuron, right? Is it clear? In our memory, we have 86 billion neurons. I'm talking about one single neuron, right? Any questions? So how do you actually update the words? We'll talk about in next session. So we have only 3 minutes. Okay. So that is the intro with artificial neural networks. So similarly, we can have AND gate, OR gate, and loss function is nothing. Is the difference between expected output, actual output, and the predicted output. So actual output is given in the data, and predicted output, the prediction by the model. So the difference between y and y hat is the loss, nothing else. So next, in the next session, we will start with the loss function. So so these are very commonly used loss function, like L1 loss, mean absolute error, L2 loss, mean absolute squared error. So here y, so it's absolute value or square, so it doesn't matter which one comes first or not. So y or y hat minus y, so is a like a sum. So in a data we not have a only single examples, we have a set of examples, or in a sense, so we actually calculate their sum divided by n. So we have a mean absolute error, which we normally use for regression problem, mean squared error. So mean base bias error. So mean squared logarithmic error, we just use logarithm that normally used for so we'll see that in binary class classification problem or multi-class classification problem we can use log, but here mean squared logarithm error is used for regression problem. We have Huber loss. So I think we can stop here now. So in next session we'll talk about Huber loss and binary loss and categorical cross entropy loss. So then we'll go for empirical risk minimization. Then we'll talk about gradient descent, and we'll give a practical example using gradient descent. And then we'll talk about CNN and RNN, right? So we'll talk about the overfitting problem, how we address the overfitting problem in neural network. So I think it is enough for the first session. Right. Thank you, everyone. So if you have any questions, so still we have 1 minute to have questions. We can have 1 or 2 questions. Okay. Okay. Thank you, everyone here to be here. Thank you. Okay. Hope to see you in the next session. Take care.
Thank you, sir. I am requesting session moderator to come forward and closing the session. For closing the session.
Thank you for joining the session. And now we will go to the auditorium hall for the inauguration ceremony. Thank you.
Thank you all. Hello. For all of our session chair and speaker, there is an announcement for the organizing com. That is all your breakfast collected from the teachers, students dormitory, teachers dormitory for the food section. It's an announcement for the speaker, moderator, and the volunteer. Please collect your breakfast from the food banner.